My bulb is starting to go. It's not as bright as it used to be. So complementary, think of 90 degrees. It's right to complement someone. Supplementary, think of 180 degrees. Okay. So we're going to apply that to our scenarios here. So maybe grab a highlighter, right? You might encounter angles that are outside the triangle. You should try to find at a straight angle or a right angle to possibly find an angle inside the triangle. That's your goal now. So let's read this one. A captain of a boat sees 2 points of land. So this is the boat, right? So spots point C at 1.8 kilometers east. That shouldn't surprise us, right? This is east. From the boat's perspective, it's going straight east. So be mindful of those details. And point A is at a bearing of 12 degrees. Okay, so you see that this is the north line. This is north up here. What do we know about the north and the east line? At what angle do they meet? The north-south and the east-west, they meet at a 90, right? They meet at a 90. So we have over here a scenario. Let me write this out here. Okay, this is the west and east. This is north and south. And there's a 90 there, okay, at this corner. So in order, if this is 12, I don't like it that it's way up there, but it doesn't matter. This angle right here, angle B, is going to be found by going 90 minus 12. The 12th degree bearing here, this sliver here is 12 degrees. I'm going to subtract it, and I get 78 degrees. Okay, so that's 78. I can write it in inside here. So that would be worth a mark on a test or on even on the provincial exam. You finding this part right here, I would circle that, would be a mark basically. Okay, and now we can solve. How far is the boat from point A? Read the question again. How far is the boat, so the boat here, from point A? Like what is this distance here? This is going to be more work than just do a sine law, slap it in, and solve it. It's going to, yeah.
Oh, what is the center of the...
This north.
Yeah.
Yeah. Let's make clear that that's north, right? This is north here. The dashed line goes straight north. Okay, so what can we do here? We know we have a pair, correct? At the minute you found this one, because remember you had nothing inside the triangle, not a single angle. You can't solve as is, right? You need a little something. If you had all three sides, that'd be a different story, right? But we don't. So this is sine law, right? Tells us we're going to use sine law. So let's see what we can do. We're going to go sine of 78 degrees over 2.5 kilometers is equal to, what can we do on the other side? What is possible right now? Look at the triangle. You're like, well, Mr. Dirksen, I want to solve this side here. So what can you do? Nothing right now. Okay, so when that happens, I want you to think this way. What do I have? I have this 1.8, correct? So put the 1.8 down. What does that allow you to solve for? In this case, angle A, correct? So let's just do it. Even though it's not going to solve our ultimate question, that's what the first step you take. So we're going to go sine of A. That's all we can do right now. And let's go ahead and solve that. Make sure you're conservative with your space. That's why I started up here. So I'm going to go 1.8 times sine of 78 over 2.5. Angle A is going to be sine inverse. Okay, go ahead and grab your calculators and do the typing. I want you to make sure you're very comfortable with this, how to find the angle, do you get the right angle, all that stuff. You don't want this to be a problem come test time. Okay. So I multiply the top, I divide it by what's at the bottom because you want it to start with a 0. If not, you need to go back and check. So I'm going to go shift, sine, and there you have it, 44.77 degrees. It's not my final answer, so I'm just going to underline it. That would have been step number 1. What else can you do now? Still copying down. You've got how many angles right now? 1 and 2. So you can find this third angle, which will allow you to solve for that side across here. Okay, so let's go ahead and do that. Angle C is going to be 180 minus 78 minus 44.77. It's 57.23. Also important to me, but not the final answer just yet. So let's solve for the last piece here. Let's call this let's put a question mark here because that's the ultimate, the one we want to find, right? Let's call that x. X is equal to question mark. So we're going to go sine of 78. I like to stick with the pair that was given to me or that we determined right at the beginning. Now we're going to go sine of 57.23. Right, this is angle C, by the way. Over x. And there's no inverse required here. We're just going to go 2.5 times sine of 57.23 divided by whatever is left, right? You cross multiply here, and then you divide by sine of 78. This is probably the one unit where I would say this is where having your own calculator pays off. So that's 2.15 kilometers. This is the final answer. Right? We'll say distance from boat to point A. You want to, I don't know, maybe just watch how I do this. I'm going to chunk it up in steps. I did this part first. Actually, step 1 was this one. Step 1, step 2, step 3, and then this is my last one here, right? step 4. I don't know if that helps you to kind of follow along next time if you look at it again. Okay, I want you to try page 36. So it's kind of like I do one, you try it, right? And then I'll do the supplementary one, and then you'll try one. So try page 36 real quick. If you feel like, no, I want to finish this, I'm not listening right now, right? Like, go for it. I don't want to force you to listen to me, but I will go over this, and then I will do a supplementary angle as well. I just want to clarify this one here, guys. On 36, this may throw you off. South 20 degrees east. What is that? That's actually a way to talk about direction, like where you're actually, which direction you're going to be headed. And so that 20 comes in here. And if you think about it, do you see that arrow there? I tried that to be an arrow. So from the south, you measured 20 degrees east. That's literally what I did there. Okay. So at this corner, picture this, folks. If you have a T, right, there's 90 degrees all around. And if you cut that, just watch carefully. If you do this, and I know this is 30, what do you think this is going to be? 60, right? Like they're complementary. They're 90 combined. Okay, so that's what's happening here. So in order for you to find this piece here, you know that is 70, right? Like, because they are complementary. So I don't need you to necessarily show me the work. You can just slap the 70 in there, or you can just say, right, 90 minus 20 is 70, and then that's what you maybe tell yourself that's how you came up with that 70, or else you cannot solve that triangle, right? There's no way. And now you have a side angle side, right? So you need to use cosine. I'm going to solve, it's asking the distance traveled from the turning point to the final destination. So this is the side that I'm interested in solving. And when I looked at your work, I was very, very happy with it. Some of you might have had a kink here or there, but that's not necessarily our focus right now. Oh, I'm going to run out of runway here. If you type all of that in one shot, you get 55.746, and that keeps going. If you take the root, don't forget to take the root. Would 55 make sense in this context? It's too big, right? Like 7.9, 3.5, it's too big. So rooting it, you get 7.47 kilometers. Okay. Next, it's asking the angle at the turning point. So it wants this angle right here. So it's asking, what is angle T? That's basically what it's asking. Give it a letter if it doesn't have one. Go for it. Whether you use sine law or cosine law, it doesn't matter. Sine law, you use this as your pair, right? Sine of 70 over 7.47 is equal to sine of t over 7.9. Which angle is going to be bigger between these two? Look at the sides. This has a longer side, right? So t will be bigger than 70. Okay? So we go sine of t is 7.9, sorry. 7.9 times sine of 70 over 7.47. Angle T is sine inverse of whatever you get when you type that in, which is 0.1078. I'll just spare you the details on how to type that in. Oh, No, sorry. My bad. I'm looking at cosine law when I did this. Sorry. Let's do this again. I didn't use sine law, so I'm going to actually have to type this in. That's what you get. 0.993 ... We use inverse sine. It's 8361. Okay. What did you when I used cosine law, I got 81. Sorry, I got 8381 using cosine law. Using cos law. Anybody want coleslaw? There you go. So it's slightly off, and that's just to be expected. You will not lose any marks when that happens. Okay. So let's see here. Angle T, right, would be this one right here that I found later on. Okay, so this is complementary angles. Let me just peek here. Okay, we're good. We're gonna go back in time, and I'm gonna ask you to go with me to page 33. This is gonna be probably the last, maybe one more example, but I'll give you some work time after this one again. Okay, page 33. You want to write at the top supplementary angles. It sticks out more when you flip through your notes. I'm going to put that nice and big and highlight. What do you notice about this triangle? Not a whole lot of information, right? Okay, let's find some information. It's probably in the text. A ship travels south from port for 2 hours at 35 kilometers per hour. So this is the port. This is where it all starts. Then changes course, travels 20 degrees west of south. What in the world is that saying there, right? 20 degrees west of south is in that order. So it means that you're going 20 degrees west from the south. Okay. So there it is. If you said exactly southwest, for us that's 45 degrees. Like if you go perfect, if you go southwest, it'd be 45 on either end. Just so you know. Yeah, but technically, yeah. I know what you were trying to say. We're so picky, right? And then when it changes course, it's 3 hours at the same speed. Okay, going this way. How far are you in 5 hours? Okay, so here, watch this part. To calculate distance, we simply multiply the speed times the time. Okay. So if we go for 2 hours, right? We go 2 hours times 35 kilometers per hour. We will have traveled 2 times 35, 70 kilometers, correct? So this 70 here is what we're going to put into our triangle, 70 kilometers. Right? From port to, let's call this turn right here. At that point, you turn that way. And for this stretch here, you travel what? 3 hours at the same speed, right? So we're going to go 3 hours times 35. What was that, Aiden? 105, thank you. 105 kilometers. So that 105 I'll place down here. Oh, this is side angle side, Mr. Dirks. I'll just use the 20. What's wrong with using the 20? It's not inside my triangle. Go ahead. So I want this. I want this part right here. There's no 90 there, is there? There's no two lines meeting like at a T. It's just a straight angle right here. So if this is 20, then this will be 160. Okay, this is 160 degrees. So I went, for angle T, I went 180 minus the 20. So angle T is 160 degrees. Okay, this is very important, that step. Am I going to give you, I'll just tell you this, right? There's a straight line there. And if you want to do this, think of a hat, right? From end to end, it's 180. If you pick any point and you go from this side to that side, that's 180 degrees. So if somebody slices this up and tells you, hey, this is 20, then you know this is 160, right? Like on this end. So all you've done is you split it up, and we use that property to help us find the other side, so to speak, right, of that angle. And now we've got one inside. Now have a SAS, right? Use cosine. So let's do it. So, okay, on a test, you would get a mark for each of these. You would get a mark for the 70, a mark for the 105. You would get a mark for finding the 160. And then you would get 2 to 3 marks for using cosine law. It depends on the scenario. Okay, so here we go. What are they asking us to find? How far is the boat from the port after 5 hours? Because you got to know 2 hours and 3 hours, that's a 5-hour trip. So it makes sense. So we'll call this X question mark. So to find X, you guessed it, we just use the formula, and the numbers will be bigger than what you're used to. Don't let that scare you, okay? You'll be just fine. If you do this in part, you remember me talking about the obtuse angle here, the cosine of 160. What are you going to get at the end here? Cosine of 160 is a negative. You're going to get a negative. So that negative multiplies all out here, and we'll meet that negative out here, turning this whole end piece here into a positive. So it's basically this plus whatever you get here. So you have to watch out. So those of you that need to be worried about this, I think I've already talked to you. So I'm just going to go ahead and, if you type this in one shot, you do not need to worry about it. So it's a big number, but that's okay. Let's take a root. There we go. So again, we added layers. We started with just this at the beginning, and now we're just backing up a little bit and adding some layers to get to this point where we can actually use the cosine law. Okay. All right, so for the rest of the class, I want you to try 34 all the way to 36, but 36 we kind of did already. So your homework is page 34 to 30. I'm going to go 36. Maybe you didn't get to it. Maybe you weren't writing it down, so I'll say, hey, I'll do it anyways. And the 34, 35 is all about supplementary angles. So just watch it, give it a try. There's some notation, weird notation, three-letter angle notation, all of that. So it's not just going to be slam dunk. You're going to have to do some reading and some figuring things out, but you'll be all right. And if not, ask me for help. Okay? So use the rest of the class to work, and that's it for today.